Once again, welcome back in my first video of new chapter, and that is the oscillations. This is the fifth chapter of subject physics. First, we see the introduction of the chapter. Actually, oscillations, it is the type of motion, and this motion categorized in two parts. One is the non-repetitive motion, and second is the repetitive motion. Now that the motion, the first, this motion, it is categorized for non-repetitive motion, and the second is the repetitive motion. Non-repetitive, the motion in which they do not repeat itself. Do not repeat itself. It means that its path cannot be repeated. Such a motion is called as a non-repetitive motion. In case of repetitive motion, the motion in which they repeat its motion again and again. They repeat the motion again and again. Such a motion is called as a repetitive motion. म्हणजे मोशनचे दोन टाइप्स पडतात पहा जनरली, नॉन रिपिटेटिव्ह आणि रिपिटेटिव्ह. मग रिपिटेटिव्ह मोशनमध्ये काय होते की दे डू नॉट रिपीट इट सेल्फ, म्हणजे यांच्यामध्ये मोशन रिपीट होत नाही, पाथ रिपीट होत नाही. फॉर एक्झाम्पल, दॅट इज द रेक्टिलिनियर मोशन. Rectilinear motion, the motion in which the particle moves along the straight line. म्हणजे याचा जो पाथ आहे, हा पाथ कसा असतो? along the straight line. For example, the motorcyclist moves along the straight road. Motorcycle moves along the straight road. म्हणजे अशा पद्धतीने तो एका स्ट्रेट रोडने मूव्ह होईल, and it cannot repeat its path again. Such a motion is called as a non-repetitive. इथं रिपिटेशन होत नाही मोशनचं. हे एक त्याचं बेस्ट एक्झाम्पल आहे, रेक्टिलिनियर मोशन. अँड द सेकंड एक्झाम्पल इज द प्रोजेक्टाईल मोशन. What is projectile motion? Already studied in last year, that is 11th standard. The projectile motion, it is defined as an object thrown in air moving with initial velocity, making some angle with the horizontal, and moving freely under the action of gravity. Such a motion is called as a projectile motion. Suppose there is the particle making some angle, and which is the projectile from this point O, and this motion is called as a projectile motion. For example, the bullet fired from the gun. This is the example of the projectile motion. म्हणजे बुलेट जर आपण गनमधून फायर केली तर तिचं मोशन अशा पद्धतीने येईल पहा. और द किक इम्पार्टेड टू द फुटबॉलला ज्यावेळेस किक मारली तर त्याचं जे मोशन असणार आहे ते काय आहे? प्रोजेक्टाईल मोशन. इन बोथ केसेस और बोथ एक्झाम्पल, दस पार्टिकल डज नॉट रिपीट इट्स मोशन अगेन अँड अगेन. सच अ मोशन इज कॉल्ड ॲज अ नॉन रिपिटेटिव्ह मोशन. द सेकंड वन इज द रिपिटेटिव्ह मोशन. मग रिपिटेटिव्ह मोशनचे एक्झाम्पल कोणते? द फर्स्ट एक्झाम्पल इज द सर्क्युलर मोशन. What is the circular motion? Just we have to study in the first chapter. The motion in which the particles moves along the circumference of circle is called as a circular motion. For example, electrons. These electrons which is moves along the circular path around the nucleus. This is the circular motion. Or the motion of the earth around the sun or other planets, or the motion of the moon around the sun. These are the example of the circular motion. The second, these electrons moves along this circular path. It complete one rotation, again it perform the second rotation. There is a repetition again and again, and due to this it is called as a repetitive motion. It's cover the path again and again after definite interval of time. जर आता त्याच्यात आता याच्यात जर टाईमचा क्रायटेरिया लावला आफ्टर डेफिनाईट टाईम इट इज द पिरियडिक मोशन. नेक्स्ट आर्टिकलमध्ये आपल्याला ते परत डिटेलमध्ये पाहायचं असेल. नाउ द सेकंड वन इज द रोटेशनल मोशन. रोटेशनल मोशन. Rotational motion, what is meant by rotational motion? For the rigid body which is moves along the fixed axis and whose particles of rigid body which perform the circular path with different radii and the center of these particles lie on a fixed center, and such a motion is called as a rotational motion. For example, this is the rigid body, it having the number of small particles. Suppose this is the axis of rotation. This particle perform the rotational motion about this axis. This is called as a rotational motion. Or another example is the motion of the blades of the fan. Suppose this is the fan, this is the axis of fan, and these are the blades. These are the blades of the fan. And this fan which is rotate about its axis, this is the rotational motion. म्हणजे इथं सुद्धा ब्लेड काय करतायत, त्या पाथ त्यांचा जो पाथ आहे तो रिपीट करतायत अगेन अँड अगेन, त्याच्यामुळे त्याला काय म्हटलंय रिपिटेटिव्ह मोशन. अँड थर्ड वन इज द ऑसिलेटरी मोशन. ऑसिलेटरी मोशन और इट इज ऑल्सो कॉल्ड ॲज द व्हायब्रेटरी मोशन. व्हायब्रेटरी मोशन ऑल्सो कॉल्ड ॲज द व्हायब्रेटरी मोशन, जे आपल्याला ह्या चॅप्टरमध्ये इथं पाहायचं आहे. ॲक्च्युली इट इज अ वन टाईप ऑफ मोशन. इट रिपीट्स इट्स पाथ अगेन अँड अगेन. त्याच्यामध्ये पण काही कंडिशन्स आहेत, आपल्याला नंतर डिटेलमध्ये आपण ते पाहणार असो. बिफोर स्टडिंग द ऑसिलेटरी मोशन वी स्टडी द सम definition regarding to this, and then these definitions are very useful to understand the concept of oscillations. The oscillatory motion is the repetitive motion. Oscillatory motion समजून घेण्यासाठी त्यासाठी आपण पहिली डेफिनेशन पाहतोय, periodic motion. The periodic motion, it is defined as the motion in which it repeats itself after a definite interval of time. म्हणजे मोशनचं जे रिपीट होतं पाथ ते एका ठराविक वेळेनंतर पाथ पुन्हा काय करतो, पार्टिकल पुन्हा त्याचा पाथ परफॉर्म करतो. सच अ टाईप ऑफ मोशन इज कॉल्ड ॲज अ पिरियॉडिक मोशन. द एनी मोशन विच रिपीट्स इटसेल्फ आफ्टर अ डेफिनाइट इंटरवल ऑफ टाइम. फॉर एक्झाम्पल द अर्थ. एक्झाम्पल द अर्थ विच इज मूव्स अराउंड द सन. मग suppose at the center there is the sun and this earth which is rotate around the sun. This motion is the periodic motion. Why it is the periodic motion? After each rotation or after each complete oscillation it require a fixed time, definite time, and this time is near about 365 days or 1 year. म्हणजे पहिलं रोटेशन त्याने कंप्लीट केलं अर्थने अराउंड द सन, दॅट रिक्वायर्ड टाइम इज 365 days or 1 year. अगेन इट परफॉर्म द सेकंड रोटेशन, दॅट पिरियड और टाइम मस्ट बी सेम और कॉन्स्टंट, अँड ड्यू टू दिस इट इज कॉल्ड ॲज अ पिरियडिक मोशन. म्हणजे पार्टिकलला प्रत्येक मोशन परफॉर्म करण्यासाठी जर सेम टाइम लागत असेल, कॉन्स्टंट टाइम लागत असेल, तर त्याला म्हणायचं पिरियडिक मोशन. The motion of a minute hand, second hand or hour hands of a clock, these are the also periodic motion. The second काटा आपण घेतला, second hand of the clock which is its period is the fixed 60 seconds. After each 60 seconds it perform the same path, and that is the periodic motion. Okay, the next definition, that is the period, or it is also called as a periodic time and represented by the letter capital T. Period or periodic time, the time taken for particle to complete one revolution or one oscillation is called as the period or periodic time. Time taken for, it is defined as the time taken for a particle to complete one revolution. is called as the period or periodic time. In case of earth, आताच आपण एक एक्झाम्पल पाहिलंय. द अर्थ इज द रिव्हॉल्व्स अराउंड द सन. द इट्स पिरियड इज द 365. मग याचा जो पिरियड आहे त्या एक्झाम्पलमध्ये मग ती किती असणार आहे? 365 डेज इन डेज और इन 1 इयर. जर इयरमध्ये घेतलं तर 1 इयर. मग दिस इज द पिरियड. म्हणजे एक रिव्होल्यूशन पूर्ण करण्यासाठी त्याचा जो काही टाइम असेल त्या टाइमलाच काय म्हणतो आपण? इट इज कॉल्ड ॲज अ पिरियडिक टाइम. 365 in case of earth revolves around the sun. Now this is the period is nothing but the time, so its unit is the second. त्याचं जे युनिट आहे, युनिट आपण जे डिफाइन करणार आहोत तो काय आहे? सेकंद. सेकंद इट इज द युनिट ऑफ द पिरियड. अँड डायमेन्शन इज dimensions are the one in time, 0 in mass and 0 in length. These are the dimensions of the period. Okay, what is meant by period? The time taken for a particle to complete one revolution or one vibration or one oscillation, it is called as its period. In case of second hand of a clock, when the second hand performs the one rotation, its period is 60 seconds. In case of minute hand, its period is 60 minutes. And in case of hour hands, its period is 12 hours. These are the periods. After each rotation, it requires the same time or constant time. And such a motion is called as the periodic motion. The oscillatory motion, or it is also called as the vibratory motion, and it is defined as it is the periodic motion. It is the periodic motion in which particle repeatedly moves to and fro along the same path about its mean position is called as the oscillatory or vibratory motion. आता त्याच्या डेफिनेशन मध्येच काय आलंय पहा? इट इज द पिरियडिक मोशन. हे कसं आहे? पिरियडिक मोशन और पार्टिकल रिपीट्स इट्स मोशन आफ्टर अ डेफिनाइट इंटरवल ऑफ टाइम. हे आताच आपण डेफिनेशन पाहिली. तर ऑसिलेटरी मोशन नंतर आपण त्याची इम्पॉर्टंट नोट पाहणार असेल. ऑसिलेटरी मोशन्स आर ऑलवेज पिरियडिक मोशन in which particle repeatedly moves to and fro. For example, suppose this is the particle. It is at position O. It moves to and fro, just like that, to and fro. This is its equilibrium position. याला आपण काय म्हणतो? Equilibrium position. Suppose this is the position A and this is the position B. This position is called as the mean position. These two are the extreme position. Such a this particle moves to and fro. In case of in other example, it also moves up and down. काही याच्यामध्ये तो अप अँड डाऊन असाही तो मोशन काय करत असेल? परफॉर्म करत असेल. म्हणजे ह्या त्याच्या काय झालं? एक्स्ट्रीम पोझिशन आणि हे त्याची मेन पोझिशन झाली. इन केस ऑफ सिंपल पेंडुलम, इट मूव्स टू अँड फ्रो अलॉंग द सेम पाथ. त्याचा पाथ सेम आहे. म्हणजे हे काय आहे? त्याचं रिपिटेशन होतं. आपण सुरुवातीलाच पाहिलं कारण ऑसिलेटरी मोशन काय? रिपिटेटिव्ह मोशन. मग दिस इज द एक्झाम्पल ऑफ द ऑसिलेटरी मोशन अँड इट इज द पिरियडिक. ते कसं आहे? पिरियडिक. ॲट एव्हरी कम्प्लीट रिव्होल्यूशन इट रिक्वायर द सेम टाइम. ड्यू टू दिस इट इज कॉल्ड ॲज द पिरियडिक मोशन. नाऊ द ऑसिलेशन, जे आता आपण जो चॅप्टर पाहतोय तो आहे ऑसिलेशन. मग त्याचं जे आहे वन कम्प्लीट टू अँड फ्रो मोशन ऑफ द ऑसिलेटिंग बॉडी इज कॉल्ड ॲज द वन ऑसिलेशन. म्हणजे पार्टिकल मीन पोझिशन ज्यावेळेस परफॉर्म करेल त्यावेळेस समजा तो एक्स्ट्रीम पोझिशन आला बी टू ओ, अगेन ए, अँड द फायनल कम्स टू इट्स मीन पोझिशन ओ, देन वी कॅन से दॅट इट इज द वन ऑसिलेशन. त्याला आपण वन ऑसिलेशन म्हणतो. पहा, द वन कम्प्लीट टू अँड फ्रो ऑफ ऑसिलेटिंग बॉडी इज कॉल्ड ॲज द one oscillation. Now the examples. Now examples of the oscillatory motion, that is the rocking of the cradle. लहान मुलांचा जो पाळणा आहे पहा, that is the example of the oscillatory motion. It moves about its to and fro motion, or the swinging of a swing, जो झोका आहे तो सुद्धा ऑसिलेटरी मोशनचं एक्झाम्पल आहे. नंतर द मोशन ऑफ द व्हायब्रेटिंग ट्युनिंग फोर्क्स. जो ट्युनिंग फोर्क आपल्याला माहिती पहा, इज द ट्युनिंग फोर्क. व्हायब्रेशन्स ऑफ दिस ट्युनिंग फोर्क्स, vibrations of the prongs of the tuning forks, it is also perform the vibratory motion. When we strike on the rubber pad, these prongs get vibrate and it perform the vibratory motion and check to and fro as motion wheel. Then the vibrations in case of musical instrument, the vibrations of a string of sitar, guitar, violin, this is also example of the vibratory motion. Suppose this is the string which is the fixed at the both ends, and when we pluck of this string, it get vibrate about their mean position. These are the some examples of the oscillatory motion, or it is also called as the vibratory motion. The one important note about this vibratory motion is that the oscillatory motion is a periodic motion. Oscillatory motion is periodic motion, but periodic motion not need to be oscillatory motion. This is the important note about the oscillatory motion. It is a very important. The oscillatory motion is a periodic motion. All oscillatory motions are the periodic. Why it is the periodic? For example, in case of simple pendulum, suppose this is a simple pendulum which is displaced from its stable equilibrium and release. It performs the motion to and fro about its mean position. In one oscillation, for example, its initial displacement is 50 centimeter, or we take in SI system meter, and its velocity it is the 10 meter per second. When we increase the time, its displacement goes on decreasing. नंतर जसं टाइम इंक्रीज होईल त्या पद्धतीने त्याचं डिस्प्लेसमेंट काय होणार आहे, कमी होत जाईल. नंतर तो या पद्धतीने येईल, नंतर इथं, आणि शेवटी तो काय त्याच्या मीन पोझिशनला येईल. म्हणजेच फर्दर दिस इज द 40, then 30, its displacement goes on decreasing, then 20, then with respect to displacement, its velocity also goes on decreasing. 10, then 8, then 6, then 4. We have to find its period. Suppose that time, you know that the definition of velocity is equal to the rate of change of displacement with respect to time, or time is equal to what is the time? Time is equal to displacement upon velocity. Now here displacement it is the 50 and divided by velocity is 10. What is this? Is the 5. This is the 5. And we get the period is the 5 seconds. In this first case, period is the 5 seconds. म्हणजेच हा period किती आलाय? 5 seconds आलाय. This period is equal to displacement upon velocity. In this case, what is period? Period is the 5 seconds. Again, we get the 40 divided by 8. 40 divided by 8, we get the period 5 seconds. Again, 30 divided by 6, 5. 20 divided by 4, 5. In each case, the time is the constant. This time is the constant, and due to this, oscillatory motion is the periodic in motion. This is the important note. All oscillatory motion are always periodic in motion. Okay? सगळ्यात महत्त्वाचे हा कन्सेप्ट आहे पहा. म्हणजेच पिरियडिक मोशन म्हणजेच आपण आत्ताच पाहिलं, द मोशन इन विच पार्टिकल रिपीट्स इट मोशन आफ्टर डिफिनाइट इंटरवल ऑफ टाइम. मग आता ह्या केसमध्ये काय आहे, त्याचा प्रत्येक डिफिनाइट टाइम किती आहे? सपोज 5 सेकंद. आफ्टर इच 5 सेकंद it repeats its motion. That is the periodic motion. Next part, the periodic motion not need to be oscillatory motion. म्हणजेच काय सांगितलं इथं की पिरियडिक मोशन हे ऑसिलेटरी मोशन असतीलच असं नाही. मग समजा आपण एक पिरियॉडिक मोशन घेतलं. फॉर एक्झाम्पल द अर्थ रोटेट अराउंड द सन, that is the periodic motion. After every oscillation the earth required the same period, that is the 365 days. But this is the oscillatory motion. Earth cannot vibrate about their mean position. It is not a oscillatory motion. Actually it is the periodic, but it is not a oscillatory motion. Okay. Or electrons or the motions of the minute hand, second hand, hour hands of the clock, these are all the periodic motion but not oscillatory motion. सगळ्यात महत्त्वाची नोट आहे, रिमेंबर ठेवावा. ऑसिलेटरी मोशन इज द पिरियडिक मोशन, बट पिरियडिक मोशन नॉट नीड टू बी ऑसिलेटरी मोशन. लक्षात. द नेक्स्ट डेफिनेशन and that is the frequency. This is also important definition. The frequency, the number of oscillations. It is defined as the number of oscillations performed by particle per unit time. म्हणजे एका युनिट टाइममध्ये, म्हणजे एका सेकंदामध्ये त्या पार्टिकलने किती व्हायब्रेशन किंवा किती ऑसिलेशन्स कंप्लीट केले असतील, that physical quantity is called as the frequency. The frequency is measured in hertz. SI unit है पा. Actually its formula, it is given by this frequency is equal to, it is the reciprocal of period 1 upon t. The t, it is the period which is measured in second, and this SI unit is the per second from the formula, or it is also expressed in hertz. And its dimensions are 1 in time. This is the reciprocal. Then it become -1 in time, 0 in length and 0 in mass. These are the dimensions and SI unit of the frequency. The number of oscillations performed by the particle per unit time means per unit second. SI सिस्टीम मध्ये जर आपण घेतलं टाइम सेकंड मध्ये, तर पर सेकंड असे आपण डेफिनेशन तयार करू शकतो. पहा, दिस इज कॉल्ड एज द फ्रिक्वेन्सी. द नेक्स्ट डेफिनेशन, इट इज द सिंपल हार्मोनिक मोशन. इन शॉर्ट इट इज ऑल्सो कॉल्ड एज द SHM, simple harmonic motion, and it is defined as it is the simplest kinds of motion in which it is the oscillatory periodic motion. Just we have to discuss, the oscillatory motion is always periodic motion, in which the every particle of oscillating bodies moves to and fro about its mean position along the fixed path. It is called as the simple harmonic motion. The simple pendulum, it is the best example of the simple harmonic motion. When this body or a simple harmonic motion is oscillating body which is displaced from its stable equilibrium and release, it vibrate about their mean position along the fixed path, and this motion is a to and fro. Such a motion is called as the simple harmonic motion. In some example, the path is a straight line. स्ट्रेट लाईन पाथ. जर काही याच्यामध्ये जर स्ट्रेट लाईन पाथ असेल, देन इट इज कॉल्ड ॲज द linear simple harmonic motion. For example, suppose that the string, its one end is the fixed to the rigid support, and other end which is the attached to the block of mass m. When such a block we press toward the right side and release, and such a system which is kept along the horizontal frictionless table, this block which is moved about its mean position to and fro, the path of this spring is the straight line. Such a motion is called as the linear simple harmonic motion. Or the some cases the path is the arc of a circle. काही याच्यामध्ये जो पाथ मिळणार आहे, it is the arc of circle. Such a motion is called as the angular simple harmonic motion. मोशन. द सिंपल हार्मोनिक मध्ये पुन्हा दोन टाइप्स पडले पहा. जर पाथ स्ट्रेट लाईन असेल, when the path is a straight line, then it is called as a linear simple harmonic motion. And when the path is the curve, just like the arc of a circle, या पद्धतीने arc of a circle, then it is called as the angular simple harmonic motion. The next, the term linear simple harmonic motion discussed in detail in next video. Thank you.